Hello, everybody. Welcome back to the Polymath Experience. Today, we're going to be covering U-Substitution. Are you ready? Let's get into it.
Here's how you derive the U-substitution formula.
You start with the chain rule. Once you have the chain rule,
You integrate both sides of the equation. After integrating both sides of the equation,
you see gx here. What you're going to do with gx is you set it equal to u. And if gx is set equal to u, this implies that the differential of u equals g prime of x dx. And then you plug this information into the equation, and it gives you the antiderivative of f of g of x times g prime of x dx equals the antiderivative of f of u du. If gx equals u, this implies that the derivative of g of x equals the derivative of u. Because the derivative of g of x is the same as saying the derivative of g prime of x, and this is also equal to the derivative of u, then we simply multiply both sides of the equation by dx. Therefore, du equals g prime of x dx. Let's try our first example. Make sure to pause the video and try this example out on your own before watching my explanation. Our first step is to rewrite sine cubed of x as sine x to the third power. This makes it easier to see the function within the function. The derivative of sine of x is cosine of x. Remember that the inner function here, g of x, is right next to its derivative, g prime of x. By setting u equal to sine of x, this implies that the differential of u equals cosine of x dx. We then plug this information into our equation, which gives the antiderivative of u cubed du. Note that we are now differentiating with respect to the variable u. We then use the power rule for integration. When we have some quantity, u, raised to a power, we receive the quantity raised to its initial power plus 1 over the initial power plus 1. And because this is an antiderivative, we add the constant c. The last step is simply to plug in our values. Because we take this equation, and because u equals sine of x, we put sine of x in the place of u. So our final answer is sine to the fourth of x over 4 plus c. Example 2. Remember, pause the video and make sure you try these examples out on your own before you listen to my explanation. For this problem, we set the inner function u equal to x cubed plus 7. This implies that the differential of u equals 3x squared dx. However, this becomes a problem because we don't want 3x squared dx, we want x squared dx. Remember, with U-substitution, we're looking for g of x and g prime of x dx. So to get our g prime of x dx, we divide the differential of u by 3, which gives us x squared dx. We use the constant rule to take out 1/3, and we use our exponent rules to turn 1 over u squared into u to the negative 2. Now we can use our exponent rule for integration by turning this into this, u to the negative 1 over negative 1. This simplifies into negative 1 over 3u plus c. Now all we have to do is simplify it by inserting our value for u. So our final answer would be negative 1 over 3 times x cubed plus 7 plus c. Remember, it's an antiderivative, so we always add the constant c. Alright, this is going to be our last example. Remember to pause the video and try to work this problem out on your own before you watch my explanation. To start off, we take 5x minus 1 as our value for u. We then take du equals 5 dx. We divide both sides of the equation by 5 to get du over 5 equals dx. Once again, we substitute our values into our equation, giving us this. We use our constant rule for integration to place 1/5 outside of the integral, and then because e to the u is just e to the u, we get 1/5 e to the u plus c. We then substitute our initial values into this, giving us 1/5 times e to the 5x minus 1 plus c. Hey, you made it to the end of the video! Well, as always, thank you for watching. I really enjoy making math content, and I hope you enjoy my explanations. Anyways, till next time, this has been Max of the Polymath Experience.